Guys, this is going to be the first in a series of videos for your semester exam final or your semester final for Precal for the fall of 2023. So remember, we're only looking at the second 9 weeks. We're not spiraling and going back and using the material or testing you on the material from the first 9 weeks. We felt that this 9 weeks was very comprehensive. So here's a list of the terms and topics that we're going to be covering on the exam. So what I'm going to do is I'm going to film one of these each in a separate video so that you actually can choose what you need to watch. If you understand the fourth component on the list, the lead coefficient test, there's no need for you to have to watch the video. I don't want to make a big 30-minute video and have you searching through to look for the topic that you need to see. So these will all be individual. I will put them in a playlist on YouTube, and then I will have them linked into your Canvas. So let's get started. The first topic on the list is zeros of functions, which is where a function crosses the x-axis. These are also called roots, solutions, or x-intercepts. So we're going to go to the next page, and remember, all of these are going to be placed in your Canvas, not only the videos and the links, but I'm going to have this PowerPoint available for you as well with all my work on it. So here's the first slide. Zeros of functions are the points where the function crosses the x-axis, and the y value is 0. Y equals 0. Remember, the x-intercept is where the y is equal to 0, the y-coordinate, and the y-intercept is where the x-coordinate is equal to 0. So if you look down here, I have an axis created for you with a window of -5 to 5 for both x and y. So you can see I have a point. This point right here is considered an x-intercept, or a 0, because it is on the x-axis. The reason it is called a 0 is because the y value for it is 0. Remember, we write ordered pairs as x comma y? Well, the reason this is called a 0 is because on the x-axis, every point has a y-coordinate of 0. Think of the x-axis as the ground, as ground 0. That means that if you're sitting on the x-axis, you have not moved up, nor have you moved down. So the way I would write the coordinate for that particular point, if you look, is it's at 2, 0. My x-coordinate is 2, my y value is 0. When you have a function that crosses the x-axis, this point, anywhere it crosses, is called a 0. The other things you're going to hear it called are solutions, roots, and as we just said, they are the x-intercepts. So all four of these terms, zeros, solutions, roots, and x-intercepts, all mean the same thing. So when I look at this picture here, I can see why this is a 0. Now, if I were to place a point here, that is not a 0 because there is no 0. This point is at the location -3, 1, because now I have moved up 1. It's not a 0. Remember, the zeros have to be right on the x-axis, okay? So what I'm going to show you is I'm going to show you how to solve for a 0 both graphically and by factoring. So let's erase this here and get this to come off. All right, so let's start with example 1. If I'm over here at example 1, and let's keep the colors consistent. It says find the zeros of the function f of x equals x squared minus 4x plus 3. And it says to do this by factoring. So first of all, what's another representation we use for f of x? That basically just means y. So basically what I'm saying here is I'm saying y equals x squared minus 4x plus 3. I think we all tend to get a little confused when we see f of x because we think it looks very complex. F of x replaces y just because it generally means that y is a function of x, meaning we can't get our y value till we plug something in for x. Y depends on x. And that kind of goes back into Algebra 1 when you're talking about dependent and independent variables. So let's solve this by factoring. Well, if I want to find the 0, what's the key? What has to equal 0? Y does, right? So I'm going to take this equation and I'm going to set it equal to 0. And now I can solve this equation and find out what x values make y equal 0, which tells me where does the function cross the x-axis, because that's where y is 0. Easiest way to do this algebraically is to factor. And I will have factoring in another video. So right now I'm just going to do the eyeball factoring where we kind of split things. Here, a is not greater than 1. It might be an example 2, but that's not exactly the same as what we're doing here. But right now I'm going to keep it simple where the a value is 1, so we don't have to continue the full cycle of the AC method. So let's just solve this out. So 0 is equal to, and I'm going to factor this. Now, a lot of you struggle with the factoring. What is the only way I can split up x squared? X and x, okay? So when the a value is 1, it's going to be x and x. I'm now going to go and I'm going to look at this sign. And the only reason I'm doing this on example 1 is because this is a trinomial. It's got 3 terms. If you look over at example 2, I don't have a trinomial, okay? So I'm going to show you 3 different ways here. If this is positive, that means that your factors will have the same sign. And we talked about that a little bit in class. So what I'm going to do is I'm going to go look over at my neighbor to see what that sign is. That means both of these guys have to be negative. So now I'm set up to where all I have to do is I have to find what 2 factors go in there. So let's think about this. I've got this 3 here. That 3, I need to find 2 factors of 3 that are going to go in here. And when I put those in there, they have to add up to -4, right? What's in the middle? Well, this one's an easy one. Since both signs are the same and there's only 2 possibilities, there are my factors, x minus 3 and x minus 1. Now, again, this is not a foolproof way of factoring. I'm just showing you how to factor this without going through the whole AC method. So that's in another video. But some of you have gotten good enough to where you can work these out and factor them without going through that process. So now I'm left with the situation. Let me move this up a little bit, just a hair. I'm left with a situation where 0 is equal to those 2 factors, and they're called factors because they're multiplication. Multiplied together equals 0. So basically what that means is that either x minus 3 is 0, or x minus 1 equals 0. Those are my 2 intercepts. And if you look at each one, what makes x minus 3 equal to 0? X is going to equal 3, or x is going to equal +1. So those are my 2 intercepts. Now the way I write those, 3, 0, and 1, 0. So those are also part of the answer right there. And that's how you factor a trinomial to find the zeros of a function. So let's move on to example 2. It's a little bit different. So once again, you see that keyword zeros of the function. And we're this time looking at the function f of x equals 4x squared minus 2x. So if you look at this, it's not really a trinomial. Let me fix this. I don't know what happened, but yay. So we're going to approach this a little bit differently, but this is the same idea. F of x is equal to y. The zeros are always where y is equal to 0. So now I'm going to take this, I'm going to turn it into y equals 4x squared minus 2x, because y and f of x are one and the same. And I want to find the zeros, which means I want to find where the function has a y value of 0. So this is where I am. When you look at this, though, it's not a trinomial. So when I factor this, it's not going to be exactly the same. I'm going to look for a GCF. So what is my GCF between these two terms? First, let's look at the numbers. Both 4 and 2, I can divide out a 2. And let me change the color so you can see it. I can factor out a 2. And I can also factor out an x. I can factor out a 2x out of both of these. So when I do that, remember, factoring out is the same as reverse distribution. So when I factor this out, that becomes 2x left over on the inside minus 1. Okay. So now both of these are my factors. The same idea applies that had in the first one. So in the first one, x minus 3 and x minus 1 had to equal 0. Here, both 2x and 2x minus 1 have to equal 0. So if I come over here, and I can actually do it down here, 2x has to equal 0, and 2x minus 1 has to equal 0. So let's think about these two. Let's take the 2x equals 0 and let's solve that one first. I'll come up here. How would I normally solve an equation like this? And I kind of skipped through that on the first one. I want to get the number, the coefficient in front of the variable to be 1. So I'm going to divide both sides by 2. So x is actually going to equal 0, because that leaves me with 1x equals 0. So 0 is actually one of my zeros. That actually is going to end up being the origin. So here's one of them. The next one is 2x minus 1 has to equal 0. Sorry for all the little scribblies. And then I'm going to follow the process of solving that just like an algebra equation again. So I'm going to move the 1 over. So 2x equals positive 1, because it's negative on the left and I moved it over, it becomes a positive. And then I'm going to divide both sides by 2. And those reduce, just like these reduced to 1 up there. So x equals 1/2. Those are my two intercepts. And because I ran out of room, I'll write them up here. That means your two intercepts are at 0, 0 and 1/2, 0. And those are your roots, zeros, and solutions to example 2. So let's look at example 3. Example 3 says find the zeros of the function f of x equals x cubed minus 2x squared plus x minus 1 by graphing. You can solve these by graphing, and graphing is going to be your fail-safe. I prefer that you know how to factor because it's a necessary skill, especially with all the rational functions that we have. Some things you cannot see on the graph with the naked eye. You can't see holes in a rational function by just looking at your graph on the calculator. Those holes are so small you cannot see them. So there's other situations where factoring is really necessary, but you can always factor to answer the questions and check your answers here. So once again, let's find the zeros. And this is the function we're looking at right here. X cubed minus 2x squared plus x minus 1. Now again, we're looking for where y equals 0. F of x is the same as y. But I don't really need to get into anything mathematical here if I'm going to use the calculator. So I'm going to go ahead and switch over to the calculator here on the screen, and we're going to graph this, and I'm going to show you how to find the zeros on the graph. So we have x cubed minus 2x squared plus x minus 1. So I'm going to go here. We're going to add the graph, and I'm going to type in x cubed minus 2x squared. Oh, and not like that. Make sure you arrow out of the exponent mode. 2x squared. I believe it was supposed to be minus. So let me go back and delete. There we go. And make sure you hit the minus, the subtraction symbol, and not the negative sign, because the negative sign, it'll come up with an error. Okay. Plus x, I believe, minus 1. Now let me go back and check and make sure that's what I have. X cubed minus 2x squared plus x minus 1. Okay, so we're good. I'm going to graph this, so I'm going to hit enter. And I'm wanting to know, where does this graph cross the x-axis? Well, if I look at this, what does it appear to you? It appears that the graph itself only has one x-intercept. So what I'm going to do is I'm going to hit menu. I'm going to hit trace, and I'm going to hit graph trace. Now, once I do that, you're going to see your cursor pop up. Now, I'm looking for the x-intercepts only, right? What the cursor is on right now actually is the y-intercept. So you will move. It tells you there's your relative minimum, your relative maximum. Right there, it tells you that's a 0. If you look at the bottom of the screen, you'll see it says 1.75, comma 0. Oops, wrong button. Sorry, let me get out of this. Sometimes this thing does not do what it should, and it's doing it again. Hold on a minute, sorry, apologies. Let me get back into the screen. So right here, that is your x-intercept. It appears here that we only have one. You can look at the table and look at the behavior of the graph, but it appears we only have one place where this crosses the x-axis. So you can see that's how you can do it graphically. Now let's go back and look at the other two examples that we had and see if we can solve those with graphing. So I'm going to go back to my notes page, and I want to look. Let's look at example 1. So I'm over here at example 1. Example 1 is x squared minus 4x plus 3. So let's go into our graphing. You can double tap on this. It should. Mine doesn't do it up here on the screen. There you go. And once again, let's look at our x squared minus 4x plus 3. So let me type in x squared minus 4x plus 3. Now, before I graph it, let's go back and see what we got. What did we get for our two intercepts? We got 3, 0 and 1, 0. So let's go back and let's graph this guy. All right, so you can see the red one is the one I just graphed. You're going to hit menu, you're going to hit trace, and you're going to hit graph trace. So right now you can see that the cursor is on the blue function. If you hit the down arrow, sorry, mine just likes to go a little crazy, it'll jump to the other function. So let's move to the left. And what do you see? 0. And look at the bottom of the graph. 1, 0. That's what we got. 1, 0. Let's move the other way till we get here. Oops. 0. And it's at 3, 0. So according to this, it hits the axis at 1, 0 and 3, 0, which is exactly what we have right there. So that is how you find the zeros or the roots or the x-intercepts of a function. They're also called solutions from time to time, so you will see that. But hopefully this helps you a little bit with the idea of the functions and how to find their zeros and their x-intercepts.